Alright, let's look at a few questions on three-dimensional geometry, things like area, surface area, volume, capacity, density, circumference, perimeter, and trigonometry, things like Pythagoras, SOHCAHTOA, sine law, cosine law, and areas of triangles. Start with number one. Got a field that's 91.4 meters long and 68.5 meters wide. It's not a great question because it should actually say it's a rectangular field. At any rate, assuming that it is a rectangular field, then we should be able to just do an area is length times width. And so in our case, that's going to be 91.4 by 68.5. Let's put that into the calculator then. And gives me 6,260.9 meters squared. Then it wants us to convert this amount into centimeters squared. I guess there's two ways we could do this. We could first convert each of these units. This would be 9,140 centimeters. And this would be 6,850 centimeters, because of course we multiply by 100. So that would be one approach, is that we could take 9,140 and multiply it by 6,850, and you'd find the right number of centimeters squared, 62609,000 centimeters squared. Another approach, though, would have been to take our meters squared and convert that directly into centimeters squared. So to do that, 6,260.9 meters squared. Now if I'm going to multiply by 100 centimeters per meter, at this stage my meters don't cancel out. I can cancel out only, I've got a meters and another meters over here. So for my meters to cancel out, I need to multiply by 100 centimeters per meter twice. Now I've got meters, that's meters squared in the bottom, which cancels with meters squared on the top. And so you'll notice that I'm multiplying by 100 twice. Well, that's what we do when we're converting areas into other units. We first have to multiply the length into its new unit. Then, because we're in two dimensions with units squared, we have to multiply the width into its new unit. And you can imagine if we were dealing with volume, we would have needed to multiply by yet another 100 to account for the change in units in the height. Generally, you can just look at the exponent. If we're dealing with squares, then you're going to multiply by, in this case, 100 squared. And if you had meters cubed, you would multiply by, in this case, 100 cubed. Let's express our answer to part B in scientific notation. We've got 6.2609. And how many places did we move the decimal? 1, 2, 3, 4, 5, 6. We moved it 7 places. So times 10 to the 7 centimeters squared. Let's move on to number 2. So we have to find the volume of this prism. Now the volume of any prism can be found by taking the area of the cross-sectional base times the height. So let's talk about this area of the base, or cross-section. I noticed that if this prism was a little bit like a loaf of bread, I could cut slices of it such that everybody gets the exact same shape, like this. Keep cutting slices like this, and so any one of these particular slices is going to look like the exact same triangle as we had on the front. Okay, so that triangle is the same as the triangle on the front, same as the triangle on the back. All of these different cross-sections, all of these triangles are going to be identical. So that's the area we need to find, is the area of these identical shapes that appear throughout the prism. All of these are the cross-sections. Because it's the triangle, then we should just be able to do area equals 1/2 times base times height. Now I can see what my base is, but I can't see what my height is. I need to figure out my height, and I can use SOHCAHTOA to do that. And so let's work with our height first. I can see that the tangent of, whoops, I know what the angle is, the tangent of 42 degrees is equal to opposite, which is, let's call it the x, is opposite over adjacent, 5.7. And so x, the height of the triangular base, the cross-section, is going to be 5.7 times the tangent tangent of 42 degrees. Let's work that out. 5.7 times the tangent, tangent of 42 degrees, and I got 13.06. I'm just going to verify that. Oh look, I'm in radians mode. So thankfully that didn't affect my answer in number 1, but I am going to have to change it into degrees mode. And now let's just call it the same function I just used. Okay, second enter, and now I'm going to get the right answer. I think 5.13 is the length to 3 significant figures. So 5.13 centimeters. And now my A, my area of the cross-section, is going to be the triangle, 1/2 times 5.7, there's your base, times the height of 5.13. So there's my A, and now I need to multiply by H, which is the height of the prism. Imagine if we tipped this prism over so that it is on its side. So this is on the bottom, and this is now on the top. Well, then obviously the height would be the distance between the lower triangle and the upper triangle, which is 8 centimeters. So one way you can think about the height of a prism is that it is the distance between the leftmost and the rightmost, or the bottommost and the topmost of all of your different cross-sections when you slice it up into different equal pieces. In this case, then, we can see that we've got a height of 8 centimeters, so let's multiply it through by 8, and let's work out what we get for our volume. 1/2, which is 0.5, times 5.7, times, now I'm going to be accurate, I'm going to take the answer that I had before, which was 5.132, or I can just say second negative, and that answer, it calls up the entire thing that I had a moment ago. And now I'm going to multiply by 8. This gives me as accurate an answer as possible, and when I round it to 3 significant figures, I get 117 centimeters cubed, because it is a volume. And just tying into what we were talking about in the previous problem, if I was converting my centimeters cubed into, let's say, millimeters cubed, I know that to convert from centimeters to millimeters, I need to multiply by 10. But because this is volume, in 3 dimensions, centimeters cubed, I would need to multiply by 10, by 10, and by 10. I'd need to multiply by 10 cubed in order to convert into millimeters cubed. Question number 3. I've got a point 0, -4 at point P. I've got Q is 0, 16, and I need to plot the point R, which is at 11, 16. So here's 11, and I'll come across to 16. Oh, sorry, I should have come across 11 in the x-axis, and then up to 16, and that occurs right there, and we'll call that point R. 11, 16. Now we need to calculate angle QPR. Well, from Q to P is obviously a distance of 20 units, isn't it? Because Q is 16 units above the x-axis, and P is 4 units below. Okay, if I look at the difference between 16 and -4, I get a difference of 20 units. So that's 20. And then we're looking for angle Q to P to R. Now, I don't know what the distance from P to R is, but I do know what the distance from Q to R is, and that forms a right triangle. Q to R, obviously, is a distance of 11 units. And so now in this right triangle, I should be able to use the tangent ratio for what we'll call angle theta. The tangent of theta is opposite over adjacent, so theta is the tangent inverse of 11 over 20. Let's see what we get. The tangent inverse of 11 over 20 gives me an answer of 28.8 degrees. Alright, so I've done parts A and B, and then we say that M is a point on PR 9 units away from P. So I'm just going to graph it here. It's not necessary to scale, but let's call that M such that this is 9 units. Okay. Calculate the area of triangle PQM. PQM. So I'm looking for this triangle here. Well, if this thing is 9 units long, and this one is 20 units long, and I know the angle in between, I should be able to use my area is 1/2 AB sine C formula. In this case, our two sides are 20 and 9, and the angle in between, the sine of, well, we found this angle earlier. It was 28.8 degrees. So let's type this in, then 1/2 times 20 times, and it must be the angle in between the two sides, times the sine of, and let's just use the second negative, the answer that I had previously, because that's even more accurate, 28.81, etc. And I'll get 43.4 when I round to three significant figures. 43.4. I can't include any units because there are no units given in this question. Number 4. Let's, we've been given all of this information. Thankfully, it's all been put into a diagram for us. Let's start by calculating the length of AC. Now, AC belongs to a right triangle. So we're going to use either SOHCAHTOA or Pythagoras. In this case, we'll use Pythagoras because we've been given two of the sides and we need to find the third side. So 3 squared plus 3 squared equals x squared. 18 is x squared. X is going to be the square root of 18. And if you convert that into a decimal, you're going to get about 4.24. Or sorry, yes, 4.24. Now I might actually leave it as the square root of 18 in any subsequent calculations in order to preserve more accuracy. Whoops, I forgot units, didn't I? There we go. Part B, let's calculate the area of triangle ACD. So here I've got this length, I just worked it out, it was 4.24 centimeters, and I've got this length, 4.5, and I've got the angle between them. We just did a problem like that. Our area then is going to be 1/2 times the product of the two sides times the sine of the angle between them. So then we've got 0.5 times, and instead of writing 4.24, I'm actually going to bring up the entire decimal that I had previously, because that's an even more accurate version of the side's length, times 4.5 times the sine of 25 degrees. And our area then, when we round to three significant figures, is 4.03. That's going to be in centimeters squared. And let's see, part C, we now need to calculate the area of the quadrilateral ABCD. Well, that's going to be the sum of this triangle that we just found plus this triangle. And this first triangle, ABC, is easy to find because it's a right one. Because it's a right triangle, our height is already perpendicular to the base. So we can just use triangle ABC has got an area of 1/2 times base times height, and you'll find that that's equal to 4.5. So let's just add the 4.5 to the 4.03. So that's the area of the triangle at the bottom, that's the area of the triangle on the top, and we get a total then of 8.53 centimeters squared. Alright, we'll continue on the next video.